Okay, students. So, yesterday in lecture 9, we have discussed about how to draw the entity relationship diagram by doing this ER modeling. So, you can use some online tools. You can draw using these tools like Creately, Draw.io. You can draw the ERD diagrams there. Okay, now in lecture 10, we are going to learn about the conceptual model. Now you have your ERD, entity relationship diagram. Using that diagram, you are going to convert that into some model, conceptual model. So you refer in the lecture 2, we had the modeling techniques we have studied. There you have come across what is a conceptual model, what is a what do you call logical model and physical model. So conceptual, logical, physical. So now by seeing that ERD, you are going to translate your ERD diagram model into a conceptual model. Where it is the diagram here. So you remember this one? See this one, logical layer, conceptual layer, and physical layer. So this is in the logical layer. You are seeing the output in the form of a web. And in the conceptual model, you are going to store into a table using your SQL commands like this, creating the primary keys, etc. Okay, so this is what we are focusing now, conceptual model. So now, where is your lecture? This one. So you are going to convert the previous lecture diagram into a conceptual model by following the relational database schema principles. Now, what are the objectives you are going to study and learn in this lecture is the first one. What is the method to translate? Then what are the rules of translation? And how you can do the subtype, that means supertype and subtype translations, how you can do. And different types of relationships. So existing relationships you are going to extend and create the new relationships in this diagram. So now let us move towards the first one. See, the logical model requires the greater details. So what logical model you have, it will not support the conceptual model. Okay, so you have to do the mapping between this logical level and the conceptual level. So what you will do, first one, this diagram what you studied in the last class, you are going to convert it now. So who will do this process? This persons, this role, Oracle database designers, they will do this transformation. They will transfer your design into a conceptual model. And what are the different ways? These are the few ways that you can use in order to translate your ERD. First method is using the entity translation. What is an entity? I have explained to you in the last lecture. Then subtypes determination. So what is a subtype also? I explained to you in the last lecture, that superclass, child class, like that. Then Converting the attributes, attribute translation, there is also one method. And defining the primary key in your entities and translating the relationships. So these are the different ways we can do the translation of your ERD into conceptual model. And to do all these things, this concept normalization you study in the next lecture. So normalization, your tables should be in this format, in this form, third normal form it is called, that you are going to learn in the next lecture. Now we are going to focus on these things. So let us start the first one. See here, rules. First is the approach methods. Then what are the rules is, in the entity you have to follow some rules. Attributes you have to follow some rules. When you define the primary key you have to follow some rules. And when you define the relationships you have to follow few rules. So we will see this one by one. The first heading is now entity translation. This one, entity and attribute translation. Now see, so far I am discussing you that this is an entity. Entity means like a student. In the last class I have given you, where is that ERD tutorial? This one is an entity, employee. Employee is an entity. So for that, how you are going to translate it? So after you translate, this is called a relation. This is what I gave you in the assignment. I gave you this one and I asked you to create the tables. So if this is the, if this is the entity, there is that employee. So what you are going to write now? Employee, then employee number, which is a primary key. So you have to underline it. In this one, we cannot do the underline in the notepad, in the word I am saying. Then employee last name, employee first name, employee family name, okay, then date of birth, then you have employee hire date, means joining date. So this is called a relation. So if I am drawing this, if I am creating this in the previous chapter, now you have to translate it into this one. What I told you now is the translated model. This one. Like this you have to create for this employee entity. Where is that entity? This one. This is the entity. For this entity, you are going to translate it into a relation. So what is that relation? This is the relation. This one is what? This is relation employee. So this is indicated with this letter like this, relation. So this is what called translation. So the designer will check in your model if he find like this type of, where is that? This type of entities, he has to translate it into a conceptual level, conceptual model. So for that, they will do like this. This is the equivalent of this. And here you have underline for this one. Employee number you can underline. Why? Since it's a
Because it's a primary key.
primary key. Okay, so this is the translation that we can do. So example is given to you in the next slide. You understand now this one? See, you have entity X and you have attributes like employee number, employee name, employee salary, etc. So that is translated to in this format. Example, this one. So member is an entity, you can see here in the left side. You have here member number is a primary key. So when you do the translation, it is written as like this. Member, inside the brackets, you write the member number, first name, surname, street, cities, phone number, email. Similarly for this table higher, this is the equivalent relation. So this is a relation. So this is how you do the translation for your entities. Now the subtypes approaches, what are the methods for translating the subtypes? So main super type and subtype you have. So now for the subtype, what you will do? See, one relation per subtype entity plus one for super type. So you have two relations you can create. One for the subtype and another is for the super type. So this way is easier, no wastage of memory, and this way is a complex way of writing the code. Now let us see what is this one, first type. So imagine this is your super type, you have vehicle, and the subtype you have like new vehicle or used vehicle. How you will do the translation here for this new and used? That is a subtype. So now the equivalent is shown to you here like this relation. So for the super type, you have vehicle, under the brackets, vehicle ID, vehicle type, vehicle engine, make, model, year, purchased price, sales price. These all attributes you are going to write here in the brackets. So this is for the super type. For the subtypes, can you see here? This is the only attribute you have, but you are going to do the translation and relationship here. Now see here, what is the primary key you have placed here? Yesterday I told you, do you remember in the ERD last slide? This one. So employee number is a super type in the this super type class employee. You have this attribute employee number, which is used in this subtype. Similarly here, there is that. So for your subtypes, you have to do the translation like this: vehicle ID, comma, the attribute of this one, new vehicle. Used vehicle, this one. You have cars, no? You have a car. So car is new or car is old. So car is a vehicle. So subtypes is new and used. Maybe you have like a pickup, new pickup or old pickup. Understand, this is the translation of subtypes. This is one method. Another way of translating is discussed to you in this approach too. So now in the subtype entity, see, one relation per subtype entity includes the attributes of the supertype. So here you don't have in the subtype the attributes of the supertype here, these attributes. So that now you are going to place it in your second type. So there is no separate relationship. You don't need to write any separate relationships. This is less flexible, and there is a possibility of repeated data. Redundant means copy, multiple copies of data. And this way of translation is less complex than the previous one. And you can establish the primary key foreign key relationships here. Possible referential integrity and redundancy, as I told you, the repeated values will be available here if you follow this approach. Okay, now let us see this same diagram, same supertype and subtype classes or entities, how you are going to translate. There is no separate relation for the supertype here now. Just you have for the subtypes, you are going to write the attributes, all the attributes here, along with the attribute of a subtype, along with the attribute of this used subtype. See here, book value. And the remaining all columns, all attributes are from the supertype. So this is another way of writing or translating your entity into conceptual model. See this one previously what we did. Just we are including the only one column, that is primary key, and this columns. So here also vehicle ID and this one. But instead of this one in the second, we are bringing all the columns from this supertype into this subtype. That is what is written here. So subtypes will include the attributes of the supertype. Understand this one, students?
Yes.
So this is for translating your entity relationship diagram into the conceptual model. In the exam, they will ask you, they will give you such type of diagram and they will ask you to write like this. Or they will give you this one and they will ask you to draw this diagram. Anyway, either way is possible in the exam, final exam. So maybe they will give you this one and they will ask you to write this as the answer, or they will give you this as the question and they will ask you to write this as the answer. Okay, so approach 1, approach 2. So any one the designer can follow. Now another approach, only one relation with attributes from all the related supertype and subtype entities, and no separate subtype relation. So in the supertype itself, you are going to do now. Now you are going to need one more attribute called type, like you have here. Like you have here, this one, type, employee type. With that, you can identify which is the, who is the teacher, who is the student, who is the accountant, who is the finance department, like that. So this way is also the designing is flexible, least flexible, and more unused attributes will be there, but it is easier. Now let us see this one the same way, only in the, you are shifting these columns in this super type. So MSRP is the column from this entity new, book value is the column from this one, and remaining all are from the super type: vehicle ID, vehicle type, vehicle engine, vehicle make, model, year, purchased, sales price, like this. This is the third approach. So there are different approaches before the designers. So whichever is convenient for them, flexible for them, they can use the approach. They can adopt that method. Remember this one, students, they will ask you in the exam. That's why I am telling you how they will ask you the question. Okay. Next, see
Okay, Mr.
primary keys. Now we have seen entity and attributes. Two translations is finished. Entity translation is finished, attribute is finished. Now we are talking about primary key. How to see, you have an unique id that will be equal to a primary key in the relation. So that is what we are going to do now. So primary key definition. So before, you might have seen in the relation we did not underline, but now you are going to underline and tell that this is the primary key for this entity. For this entity Z, there are two primary keys here. See, ID1, comma ID2. So this is a corresponding relation with primary key for this entity. And this is the corresponding relation for this entity with primary keys. Now the example, see, member is the uh, entity. For that, you have this one, member number, which is an underline, is your primary key. Sometimes they will write you hash also here. Sometimes they will write there as hash instead of underline. They can also write hash symbol here like this. That means that is a primary key. So you have to understand like that. Fine. Next now. Relation, the last one, relation translation. The last one. Now you see here, this is the underlined one. Before, we don't have any primary key as underlined here in the relationship. See here, no underline. See here, no underline. Why we are underlining that is because we are translating that using this primary key. Now the last one is relationship. So between one entity and another entity, like student and class or student and subjects, type of relationship. See here, one-to-one relationship implies that relationship can be related to only one another using the primary key and the foreign key, or vice versa. How? There are different ways. So one possible way is, see here, this is entity P and these are the attributes. This is entity Q and these are the attributes. So in this entity P, this is the primary key. In entity Q, this is the primary key. But how do you relate? You place the primary key of this entity P into this table or entity Q. This is one way, one method. Or you place the primary key of this child into this table, parent table. Or another way is keep both the primary keys in their referencing tables as foreign keys. So primary key of entity P is a foreign key here. Primary key of entity Q is a foreign key here. In your assignment, I have given to you like this only. Examples now see, and you have to make sure no null in the foreign key. There should be no null. And here see the relation optional. See, one entity optional and other is mandatory. So put foreign key in the optional. So P side, P entity. So foreign key, you are going to put it in the optional, wherever is the optional. This is the symbol for optional, O. Are you understanding this one, students?
Yes, Mr.
No, mister.
See, there are two entities. How we are going to put, last class I have given to you, no? When you go to the lecture 2 tutorial also, you have, I gave you lecture 2 tutorial. Where is that? What I am doing here? This is an entity employee. This is an entity department. So department number is a primary key here that is placed here in this table employee, which is a foreign key. So this is the optional side. Department employee relation. So one department may have 0 or many employees. Same way here. So imagine this is a department and this is the employee. So you are going to place the primary key of this one here as a foreign key, like I have done here. Similarly, I have done okay like that only. You understand this one now? Here we call as table, but here we are calling it as entity. This is an entity. This is an entity. So this attribute you are going to place here. Since it is a one-to-one relationship here, but optional. Which one is optional? In that side, we have to keep this one. Is this okay?
Yes, mister.
Now, another example, see here, manager and car. So car, maybe the manager can have or maybe he cannot have, 0 or 1. Car, if you are a manager, you might be given a car by the company or you may not be given by a car. So for this entity, we are going to, since this is an optional, see here, 0, this symbol O. I told you yesterday to check the symbols and learn from the internet. So this is the symbol, mandatory symbol. This is optional. O means. So wherever is optional, there only you are going to put this as a foreign key. The primary key here is becoming a foreign key here. So this is the entity for manager with this primary key with the attributes, and this entity car, this is the relation. Understand? This is one-to-one relation. This is clear, all of you? Next one is one-to-many. So if you have one-to-many, always put the foreign key wherever the many side is there. See here, in this diagram, you can find here, this is the many symbol. So the primary key of this one will become a foreign key in this one. So in the queue, you are going to place the primary key because the optional side is this one. This is the rule you have to follow. One to many relationship you have. Example like this, see here. Painter will paint the paintings. You know painter, no? Painter.
Yes.
do you call in Arabic painter? Khatat, Zihan. Okay, artist is Khatat, I think. So painter will do the paintings like this. Lohar. Okay. So many side, wherever is a many sides, that means painting. So primary key of the painter will become a foreign key here. Can you see the relationship here? Down, see, this is the actual relationship here you have in the tables. So this is the painter table. The primary key of this one, painter number 123, is becoming a foreign key here in the paintings. So you have drawn 3 paintings. 1, 2, and 3. Is there any doubts here, students?
Yes, Mister.
What doubt? Please tell me.
Mister, no doubts.
No doubt you mean. So you have to check here like this. See, painter, one painter can paint at least one or many paintings. So wherever is this many, that side you have to place the foreign key. So that is what is given here. So this is the many side. So you are going to put primary key of this one has a foreign key here. Okay.
Okay.
Now another type of relationship is many to many. Now there is an entity P, entity Q. So we are saying that many to many relationship here. So directly we cannot write like this. Many, this side also and this side also. This is not supported in the relational databases. So many to many relationships can be implemented by creating a new entity. So you have to put a new entity here, and in that way you should have one to many relationship. That is called the composite entity or associative entity or bridge entity, the name. So this will eliminate the problems of inheritance to many relationships. Now how we can do that with the example will be given here. See, the same relationship, I am dividing it and introducing a new entity. P is there, Q is there. The another column name is called PQ. So here comes the primary key of this entity, and the primary key of this entity is also placed. So when you see the assignments, in the assignments I have given to you, do you remember? Do you remember?
Yes, Mister.
Let me show you another one. Now see here, patient, doctor. So many to many relationship. So here see, doctor, patient. So primary key of the patient is placed here. primary key of the doctor is placed here. So similarly, here we are placing the primary key of this table P into this one composite entity, primary key of this table into this. So now this is one to many, one to many. Like this, it will solve the problem of the keys and it will solve the problem of inheritance here. So this is the accepted way of translation of your relationships. Direct relationships like this is not allowed. This same relationship, you can do the bridging association using this new entity. So example here, student classes. So student has many classes. So you are today having maybe 4 classes or 5 classes. So many students will have many classes. So how we can resolve these conflicts? Who is having which class? That is the reason here we are going to put here the new composite entity called enrollment. One student will register in one or more enrollments here. So one class will show in one or many enrollments. Means registrations. So you are going to change the many to many relationship into one to many relationship. From this side you have to read and this side you have to read. From left to right, from right to left. Is this clear, students?
Yes, Mr.
So example with the same example with the records, with the data. Now see student table you have, this is the ID and this is the name. And here enrollment, this is the subject code, this is the student ID and this is your grade. And what is this class timing, etc. is related here. This one to make you easily understand. Wait, I will tell you. Now, where is that? This one. Okay, is the entity student. Then you have okay, like this. So this is related from here to here. You have like one to many. From here to here, you have like this. Okay, so you can see that this student 321452, he is registered in many subjects. See here, Muad Wahad, Muad Tani, Muad Talata. Other student, other Rakam Al Talaq 321452 is registered in this course, in this course, in this course. One to many. Understand, students? Boys, one to many. Then again here, see this class, uh, this class code like 1014 is accounts, malhisab, هذا section رقم 3 هذا وقت الدرس بعدين هذا غرفة المحاضرة. Understand this one, students?
Yes, Mr.
So see, 1014 is accounts, 1018 is business, I think maybe, or computer, and 1021 is the another subject. So in this way, we can break the uh, entity and introduce a new entity called a composite entity. So this is the many-to-many translation. So let me save this one. So this is a many to many, from many to many to one to many translation. Save this file, one to m to many to one to many translation. Okay. Next is unary. That means only one entity is related to itself. So same values will be there, but the column name is just different. See here you have this entity. This entity is related to itself. Like the manager the head of the department is an employee, manages the other teachers. As I told you, dean is also employee. She will also manage the other departments or other work employees. So the reference column is this one, PK, but the same values will be there. The name of the column is different. Example, so this will be the FK for this one. Example, this one. Now, employee manages the employees. So employee ID, name, salary, and this one. Manager ID. Understand this one? Who has given some chat message or something? You understand this one, students? The last one, this one. So here, for example, uh, for employee, the data will be like this. My ID is like this 3532, comma, name is Mir, okay, salary is something like this, name, the manager ID is 3533, something like this. So this is my manager number. This is my ID, this is my manager ID. So both are employees. Data type is same, but you are giving the another meaning, another name. So this will act as a foreign key for this primary key. Students,
Mister, from where we get manager ID?
you have to introduce the same. You can have the same data type, same idea, but give some other name, any other name you give.
This example, Mister.
Yeah, this is the example I am saying.
We should put manager ID primary key or
Foreign key. If
foreign
you,
key.
this is the primary key, this is nothing but here foreign key. That means
Okay, Mister.
this is referring to employee ID. That is the meaning here. That means my manager is the head of the department. So head of the department is also employee. Now, see here, this is my ID. My head of the department is, our head of the department is 3533. His name is Gaurav. Gaurav, comma, salary something, then 3533. Now see, he is also an employee, but he is having a manager ID same. Can you see? I am the employee, he is the head of the department. So for me, this is the primary key and this is the foreign key. And for this one, this is the primary key and this is the foreign key. This foreign key is referring to this one, primary key. Note the different name for the FK attribute. Only the name is different here. So Gaurav, at the same time, he is an employee as well as he is a manager. So he himself is a manager for his ID. Now, in these relationships, where you have to put null, where you should not put null. As I told you, wherever there is an optional side, see here, this optional, it can be null. If there is a mandatory, that's solid line, it cannot be null. Fk here is, it cannot be null. Here it is an optional symbol, then you can have null values here in this entity. So this is the rule you have to follow. In the one to many but optional side, one to many compulsory, mandatory. This is what yesterday last class you have seen the crowfoot notations. Have you seen that one? No, crowfoot notations. Where is that? Not this one. This one. This one. So see the optional side. In this side is the optional. This side is the optional. That means the foreign key can be left blank. But in this case, the foreign key cannot be left blank. This is mandatory relationship. This is optional relationship. So that is what here is discussed here. See here, not null constraint can be attached. Second FK column. That means this one. So in your table you will write no, like position position ID, which is an FK, and it is number of 10 not null. What is the meaning of this one? The meaning is foreign key in the employee table cannot be null. That is why you are writing here not null in this table employee. When you create a table like this. Understand? Since this is a compulsory, this is a strong relationship, you cannot have null here. In this case, you don't need to write this one. Fk can be null, but in this case, Fk should not be null. Understand, students?
Yes.
So these are the rules you have to follow when you draw the ERD diagram, as well as you translate the ERD into a conceptual model, conceptual design. So after this only you will start writing these commands like DDL command, DML command, like insert into, then you will write like update, something like that. So first the designers will design the database. After that only the developer of the database will write this kind of code, procedure, trigger, function, package, etc. Understand, students? Voice, no sound from voice.
Understand, mister.
In the midterm, I asked you to write clearly relational algebra query. Most of the students are writing the DML queries like select, star, from, like that. In the question, when it is given clearly, you have to write that relational algebra only as an answer, like sigma, those predicate inside the bracket, name of the entity, like that. So this time I am excusing. If it is done in the final exam, it will be followed strictly there. So you have to read the question and write the appropriate answer in that one.
Mister,
Yes.
can you send answer of midterm to know what mistake?
I will show you later. Let me finish the corrections. Still, I have not corrected the other sections.
Okay.
Any other doubts? In your assignments, most of the students, they have not used data type for date properly. Date, time, year. Check in the internet what we have to use. for the time, for the year, how we have to store the values. Okay, if you have any questions, please ask. Otherwise, I will close the session. Okay, let me take your attendance. So 24 students only today. हुदा खमीज मौजूद,
Yes, Mr.
सिहाम,
Yes, mister.
मोहम्मद,
Yes, mister.
सजा अलरैमी,
Yes, mister.
हाजर अलरैमी, Hajar al-Araimi, she is there, she is somewhere. Anwar,
Yes, Mr.
Suraya,
Yes, mister.
Juhaina,
Yes, mister.
Rana,
Yes, Mr.
Fatma al-Jafri,
Yes, Mr.
Asala al-Baluchi,
Yes, mister.
Jawahar, Jawahar, मौजूद, माफ़ी मौजूद, जवाहर ईसा मोहम्मद, राशिद अल-गैलानी, राशिद अल-गैलानी मौजूद, व्हाट मैन, राशिद sleeping, Zayon,
Yes, mister.
Zainab al-Arami,
Yes, Mr.
Osama,
Yes, Mr.
Zainab al-Amri.
Yes, mister, I'm here.
Okay.
Yes, Mr.
Yes, mister.
Reem al-Jabri, Reem, Reem मौजूद,
Mr.
Reem.
Rajid here.
Okay. Reem al-Jabri मौजूद, Maryam al-Mamri,
Yes, mister.
Alia al-Harbi, Alia, Alia,
Yes, mister. I am here, Alia.
Sumaya, Sumaya मौजूद, Sumaya मौजूद, she is not answering. Asma al-Badri मौजूद, Yusra,
Yes, mister.
Aisha, Aisha al-Raji, Aisha is absent. Aisha. Basma,
Yes, mister.
K. Khalud al-Jafri,
Yes, mister.
Balkhis,
Yes, mister.
Suad.
Yes, mister.
Okay. So Aisha is absent. Reem is absent. Jawahar is absent. That's it. Okay, students, thank you very much. I will stop the presentation and recording.